This video is for you if you work 9 to 5, you know AI is changing your job, but you don't know where to start. And at the end of the day, when you finally have time to learn AI, you simply don't have any energy left. I have watched a very popular 6-hour course, AI for Everyone by Andrew Yang, and to save your time, I have squeezed all those 6 hours into this many minutes. By the end of this video, you will be more knowledgeable and better prepared to work with AI compared to many of your colleagues. The course is divided into 4 weeks. Let's get started. The first week is all about AI buzzwords, terminology, and what AI can or cannot do. The AI that we use today is not the AI from science fiction, luckily. To understand the difference, we need to look into 3 different levels of AI. So the first level, artificial narrow intelligence. It's the current reality, and some people call it weak AI because it's really good at doing one specific task or a small set of tasks like virtual assistants, self-driving cars, recommendation systems. AGI stands for Artificial General Intelligence or Strong AI. This is an ambitious future goal when AI could do any intellectual task at a human level. Then comes ASI, Artificial Superintelligence. This is just a theoretical concept. ASI would surpass human intelligence in every field. I wonder if someday when we get AGI or ASI, I most likely won't be here anymore. How about you?
I don't know.
Now let's break down AI into smaller pieces so all the terminology finally makes sense. AI is a huge collection of tools that help computers act intelligently, like answering questions, recognizing images, or making predictions. The rise of AI has been driven mostly by one tool, machine learning. A common type of machine learning is supervised learning, when AI learns from examples with correct answers. For example, you get an email in your inbox. AI looks at that email and decides if it's a spam or something that you would want to read. Another example, data about you, like what do you usually like, what do you usually click, what do you usually buy on the internet. All that data goes into AI. AI looks at different ads and then decides which one you most likely will click and will show you that ad. In the end, companies are more happier because they are making more money. Machine learning has been around for years, but it's only recently has become very powerful because of 3 things. Thanks to the internet and digital records, we all got so much data. We also got faster computers to train large models efficiently. Then we got better algorithms like neural networks, or a modern name for that, deep learning. Deep learning uses very large neural networks. These networks get better the more data we give them. In the beginning, neural networks or deep learning were inspired by how our human brain works. However, in practice, they're just large mathematical models. They take inputs and create output. Let's say you want to sell your house. You enter information like the size of the house, the location, how many rooms you have into AI. AI takes that information, analyzes and predicts the price that you can expect to sell your house for. Next, we have generative AI. I'm sure you've heard the name many times before. And most likely you already use Gen AI at work because Gen AI is hugely increasing personal efficiency for office professionals. Gen AI is usually built with deep learning and creates new content such as text, image, audio, video, code from the learned patterns in data. And now, the foundation of AI is data, and there's no AI without data. Then we have another important field, data science. Data science collects, cleans, analyzes data to find patterns and insights to help people make better decisions. AI uses that data to train models, to recognize patterns and make predictions and decisions. Data science overlaps with AI, but it's not the same thing. The output of data science is usually reports, charts, presentations, recommendations for business leaders or teams. But what is data? Data is just information like photos on your phone, text that you create every day, audio, video, or machine data. Data can be structured like your Excel spreadsheet or unstructured. GenAI mainly creates unstructured data. In the real world, data is very messy. Some values are wrong, some data is missing, some records are incorrect or inconsistent. AI teams must clean and manage these data issues before useful AI models can be built. When it comes to data, it's recommended to start small. Sometimes even a small, clean data set is far more useful than a massive, messy one. Some organizations spend a long time gathering data before talking to AI experts. This often leads to collecting the wrong data. So, AI teams and IT should be involved early to build the right infrastructure and collect the right data. But having large amounts of data doesn't guarantee better AI results. Only data that is relevant and meaningful adds value. Collecting or buying without knowing how it will be used is often a waste of time and money. So now that we have the basic understanding of AI, let's look into what AI first company means. The first time when I heard AI first, I was quite confused, but it's pretty simple. AI first company is the one that builds its products and processes around AI, so putting AI in the core of everything that they do, using AI effectively and taking full advantage of what AI does best. In week 3, Andrew Ng shares how to transform your company into an AI first company, and I will show that playbook in a moment. But first, let's look into what AI can and cannot do. AI works best when the task is simple, something you can do in less than a second of mental thought, and when there's lots of data to learn from. For example, AI can quickly detect the positions of cars for self-driving systems. It can check if a product has a defect, and it can also look at an X-ray image and determine if a patient has some problem. In general, everything that we can judge in about 1 second, AI can probably automate already now or very soon. AI tends to work poorly when the concept is complex, something that takes long reasoning and when little data is available. AI also struggles when the test data is very different from what it saw during the training. If the input changes, accuracy drops fast. For example, AI cannot reliably predict stock prices using only past prices. It cannot read the deep intention behind someone's gesture. Even we people sometimes struggle to really understand other people's gestures. And AI cannot diagnose diseases from just 10 images in the textbook. Humans, we can learn from small samples. AI needs a lot of data. In the second week, we move from theory to practice. This week is very useful if you plan to be a part of an AI project. In my current role, I lead a team of project managers, but in the past, I myself have been a project manager for many years. And based on my background and current role, I was super curious to understand how exactly do you run AI projects. And as expected, AI projects work differently. They involve lots of data, lots of experiments, and more uncertainty. And that, of course, changes how you plan, measure progress, and define success. But first, let's understand the difference between a machine learning project and a data science project. A machine learning project focuses on building a software that can learn patterns, turning input into output. A data science project, on the other hand, doesn't produce a running system. Its output is a set of actionable insights to support decision making. Often, it's a presentation for leaders or product teams explaining what the data says and what actions to take. In a machine learning project, the main steps are simple. Collect the data, train the model, and deploy the model so it can make predictions in the real world. In a data science project, the team collects data, analyzes it, and recommends actions. Finally, who can do the work? Machine learning projects can be done in-house or outsourced, because once the problem is defined, external teams can often help build the model. Data science projects are usually done in-house because they require deep knowledge of the business, its data, and its context. Let's look into some few examples. In marketing, for example, your business could decide to have 2 different designs of your website and show it to different groups of people. Data science will analyze that data and suggest you which of those designs gets more clicks, meaning more sales. Machine learning looks at what someone likes or has bought in the past and then suggests a product that the person most likely will be interested or even buy. In manufacturing, data science helps factories to understand where are they wasting money, time, materials, and then recommends which processes to redesign so the factory becomes more efficient. Machine learning systems will automatically check products for scratches and defects, which is faster and more consistent than manual checks. As a result, there will be fewer mistakes, lower cost, and higher quality products. So, data science helps people make better decisions. Machine learning automates repetitive or pattern-based tasks. And in both projects, iteration never stops. So now, how to choose an AI project? The best ideas come from bringing AI experts and business experts to brainstorm together. A good AI project sits between what AI can realistically do and what is valuable for your business. Also, Andrew Ng strongly believes that AI projects should focus on helping people improving their lives, not just making more money. After, when you have decided on which AI project you will focus on, you will also need to decide whether to buy and outsource existing solutions or build AI systems yourself. Andrew Ng suggests to not build what is already becoming an industry standard and focus on unique things that will give your business an advantage. So before committing to an AI project, do technical diligence to understand if AI can do it. Do business diligence to understand if this project will create a business value. Also, consider ethical implications and then decide between buying or building the AI solution yourself. So spending a few weeks evaluating an AI project will save you months of wasted effort and time and money and make sure that you are focusing on what really matters. So now, you have decided on which project you're going to focus on. The good news is that we don't need a perfect team to start with. Even if we don't have AI engineers, we all can take courses on machine learning. By the way, Andrew Ng has a lot of them for free. Even with the basic training, we all could deliver a first meaningful attempt. And with each next project or iteration, our solution will only get better. So how can we help our AI teams to succeed? Unlike other IT projects, AI will sometimes make mistakes, and AI is not expected to be perfect each time. Therefore, it's really important to agree with all your stakeholders upfront. How often should AI get the right answer before we can call it successful? But why can't we expect 100% accuracy? It's because there may not be enough data. Data can be messy or mislabeled. Some cases are unclear, even experts may disagree. Another thing we need to remember, AI teams will need 2 sets of data, a training set and a test set. Don't demand perfection and focus on value. AI systems can still be very valuable without being perfect. And now, are you excited to start an AI project? Did you know that there are many open source free tools that will help you move forward very quickly? Modern AI development is very open and collaborative. Many teams share tools, research, code publicly, which makes AI developments go much easier and faster. This means many AI capabilities already exist in some form. Teams can reuse a lot of existing work instead of reinventing everything from scratch. But of course, we always need to check for licenses. However, much of the stuff that we're gonna need in an AI project is already free to use and available on the internet. Next is hardware. You've probably heard CPU, GPU many times. Let's understand the difference. Imagine CPU is like a teacher and GPU is a group of students. A CPU is the general purpose processor in laptops, desktops, and servers. It handles everyday computing tasks. So like The teacher, a CPU, is good at doing lots of different tasks, explaining things, answering questions, solving problems, but usually does them one at a time. A GPU, originally designed for video gaming graphics, turns out to be extremely good at training large neural networks and have become essential for deep learning. So if GPU is like a whole classroom full of students, each student is not as powerful as the teacher, but because we have many of them, they can all work on tiny pieces of a big problem at the same time. So if you need to do one complicated task like solving a tricky math problem, then you're gonna need CPU, the teacher. But if you're gonna need to do the same task many times very quickly, like for example coloring a giant picture with thousands of squares, GPUs, the group of students, will do the work much faster because they can color at the same time together. And now, where are you going to run your AI? There are three common places. First, cloud, which means renting computers from companies like Microsoft, Amazon, or Google. Second, on-prem, meaning that you're going to buy all your machines and run everything inside of your company. There's also edge computing, when your AI needs to make instant decisions, like for example in self-driving cars, when due to safety and security, there's no time to send information to cloud and wait for it. In this week, we will cover roles in an AI team, AI transformation playbook, and also how to get started. AI is moving very fast and some job titles are still evolving. Different companies use different names, but most AI teams include a few common roles. Machine learning researchers push the limits of what's possible. They explore new ideas and sometimes publish research papers. Machine learning engineers create the models that learn from data. They collect examples, train a model, test it, and keep improving it until it gives accurate results. Software engineers build the core software so everything runs smoothly and safely. For example, in a self-driving car, they make sure the system doesn't crash and can be trusted. Data engineers organize and manage large amounts of data. They make sure data is stored safely, cost-effectively, and easy to access. Data scientists study data to find insights and help leaders make good decisions. Today, some data scientists also build machine learning models, so this role is still changing. And last, AI product managers guide what should be built. They help the team understand what's valuable and what will actually help users. But the good news is that we don't need all of them or a huge team to start with. Even one person with basic training on AI or machine learning can already begin exploring useful AI projects. And now let's look into a 5-step AI transformation playbook by Andrew Ng that most likely will work for many organizations. Step number 1, run small pilot projects. This helps team understand what AI can and cannot do, and it builds early momentum and confidence. If you don't have an AI team, you could outsource the first few projects. This brings in expertise while you learn. Pick up problems that are narrow or well-defined and data available. Step number 2, build an in-house AI team. Because outsourcing works for pilots, but long-term success requires internal capability. You'll eventually run many AI projects. Andrew Ng recommends to build a centralized team and assigning them into different functions so they can work very closely with the business. This AI team should be funded by the CEO and they could report to CTO, CIO, Chief Data Officer. The next step, provide broad AI training. Your whole company needs to learn what AI can and cannot do. Executives and senior leaders need to learn the basics of an AI strategy, and everyone needs to be able to use AI tools to increase personal efficiency. Also, there are not enough AI engineers in the world, so training internal engineers is very important long term. Step number 4, develop your AI strategy. Many executives want the strategy as a first step. However, Andrew Ng suggests that doing the first 3 steps will help you to understand what AI can and cannot do, how it really fits into your business, understanding, gaining some momentum, gaining some experience. Then you will be able to produce a very practical and realistic AI strategy for your company. And lastly, align internal and external communications. The goal is to bring everyone along the journey. Communicate clearly with your employees, customers, investors, governments, and regulators. Your aligned AI communications will also help you to recruit the limited AI talent and also position yourself as an AI-capable company. AI is a very powerful technology, but it has its limits. Therefore, it's really important to do your technical diligence together with business diligence before choosing your AI project. Team up your machine learning engineers together with business experts to find those feasible and valuable projects. AI project progress comes from the repeated cycles of iteration. Therefore, always plan for multiple attempts before you can really see good results. Traditional project planning will not work for AI projects. Therefore, measure success statistically. How often should AI get the right answer before we call it successful? We don't need the perfect team to start. Many engineers trained online can build valuable AI projects. Therefore, we should start small because our second project will be better than the first one and the third one will be even better than the second. So, where should we start? Here are the recommendations from Andrew Ng. Find colleagues and friends who want to learn AI with you. I've noticed sometimes at work, those colleagues who are also interested in AI, we talk together and then we can easily learn from each other because maybe somebody has read an article or seen something in the news. Then we discuss together and this way we can really learn much quicker. No project is a small project. Starting small and succeeding is more valuable than starting big and struggling. We should all take online courses in machine learning because this is enough to start working on many valuable AI projects. And if you can afford, consider hiring AI experts because this way your internal team can start learning from them and you will start building your internal AI expertise. Welcome to the final week of this course, week 4. So cool we made it this far. In this week, Andrew Ng talks about the real issues that are affecting people's lives today. AI is a very powerful tool, but it's not going to solve all humanity problems, and it's not a robot from sci-fi taking over the world. It's really important to remember that AI is not perfect, even though it has already created a huge economic value. There are many things that AI still cannot do, and there are many risks that we all need to be aware of. Let's break down the biggest ones. One of the biggest issues Andrew Ng talks in his course is bias in AI. You've probably heard the saying, if you have a brain, you have bias. We humans all have bias. It's natural. And here's the key point. AI that we have today is trained on the data that was created by people. So if we people have bias, that bias can show up in the data and AI can learn it too. Let's look at one example. This is Anna and Peter. They both have the same skills, same experience, same years on the job. Some companies today use AI to help with hiring, and some later realized the system was discriminating against women. Not because someone told it to, but because it learned from historical data where more men had been hired in the past. The same case when getting a loan in the bank. Two people with the same income, same credit score, same years on the job can get different decisions. For example, AI could automatically reject the loan or charge higher interest rates. Even if you personally have paid all your bills on time, based on where you live, AI could make an unfair decision. And again, AI didn't decide to be unfair, it just copied the patterns from the data it was trained on. Some systems recognize light-skinned people better than the dark-skinned people. This is because during the training, the systems, they used light-skinned people's faces more. If the system works poorly for some people, some innocent people could be stopped, questioned, or even arrested. The good news, bias in AI can be reduced. Sometimes AI confidently gives information that's just wrong. This is often called AI hallucinations. We shouldn't blindly trust AI. Instead, we should treat AI as a starting point, not the final answer, and always double-check important information. Another big issue in AI is the lack of explainability. Many powerful systems work like a black box. You put information in, you get an answer out, but what happens in between is hard to explain. Here's another very surprising limitation of AI. AI can easily be tricked on purpose. These are called adversarial attacks. Researchers have shown weird glasses can fool facial recognition into thinking someone is a different person. Stickers on a stop sign can make AI think it's not a stop sign. A small sticker can make AI think a banana is a toaster. Funny demos, but can be dangerous in real life. If attackers could fool AI, systems such as fraud detection, security systems, self-driving cars could become less reliable. And now let's look at some few risks that come with AI. Deepfakes are fake videos that make people saying or doing something they've never done. These videos can spread out on the internet very quickly and damage someone's reputation before we know the truth. This is dangerous, but at the same time, AI is used to find those kind of deep fake videos on the internet. AI can help keep people safe, but at the same time, AI could be used to watch people very closely. Some governments could use AI to track people. Where did they go? What did they do? What did they say? This can turn the protection into control if there are no limits. AI can also create large number of fake comments. It could be fake reviews, fake political opinions, or bots pretending being real people. This makes it harder to really know what's real online and reduce trust. AI can either widen the global inequality or help reduce it. And therefore, leadership, smart decisions, and education will be even more important going forward. You've probably already heard US and China are the two countries that are leading in AI development today. Even though we all are early in AI, Andrew's advice is very simple. Smaller countries shouldn't compete with big countries on everything. So instead, countries should use AIs to strengthen what they are already good at. For example, if a country is strong in coffee farming, build AI for coffee production. If it's strong in healthcare, build AI for healthcare. If it's strong in manufacturing, build AI for that industry. Your country's industry plus AI is the best approach to make your country more competitive without reinventing everything. I'm sure one question that you already asked yourself many times, or at least I've seen a lot of people asking this question, myself including, is will AI take my job? Different companies predict different numbers of jobs which will disappear or will be created. But all agree on one thing: more new jobs will be created than will disappear. This will happen only if governments and companies make the right policies. Invest in training workers with new skills and adapt quickly to new ways of working. And instead of asking, will AI take my job, we should all ask, what tasks make my job today? Out of those tasks, which of those AI can do well? If most tasks in your job can be automated, then that job is more at risk. And then the next big question, should you quit your job and learn AI? And Andrew's answer is, we shouldn't quit our jobs. He suggests that we should do our field, our expertise, plus AI. For example, radiology plus AI, marketing plus AI, finance plus AI, education plus AI. So if you already have an expertise in some field, learning on top of that AI will make you even more valuable than just learning AI alone. And therefore, let's keep learning AI and combine AI with the existing skills and expertise we already have. Congratulations! Now you're more knowledgeable and better prepared to work with AI compared to many of your colleagues. I would highly recommend everyone to watch this course. The link in the description below. For me personally, it's mind-blowing that this kind of great courses are now available for free online, and I don't even need to get out from my home. You can download for free the slides that I shared on the screen in the description below. Be epic! See you!